Now for hyperbolas not centered at the origin, standard forms of the equation of a hyperbola centered at hk, the standard form of the equation of a hyperbola centered at hk and transverse axis parallel to the x-axis is the following. We have h minus x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And what you notice now is the positive term is with the x, so the length of the transverse axis is 2a. The coordinates of the vertices is h plus or minus ak. The length of the conjugate axis is 2b. The coordinates of the co-vertices are h, k plus or minus b. The distance between the foci is 2c, where c squared is equal to a squared plus b squared. And the coordinates of the foci are h plus or minus ck. So you can see some similarities with the ellipse. Now the asymptotes of the hyperbola coincide with the diagonals of the central rectangle. The length of the rectangle is 2a and its width is 2b. The slopes of the diagonals are plus or minus b over a, and each diagonal passes through the center hk. You're going to use the point slope formula, and it is simple to show that the equations of the asymptotes are y is equal to plus or minus b over a times x minus h plus k. Now, the standard form of the equation of a hyperbola with centered hk and the transverse axis is parallel to the y-axis. Well, you can see now y becomes the positive term and x is now the negative term. Now, the length of the transverse axis is 2a. The coordinates of the vertices are h, k plus or minus a. The length of the conjugate axis is 2b. The coordinates of the co-vertices are h plus or minus b, k. The distance between the foci is 2c, where c squared is equal to a squared plus b squared. And the coordinates of the foci are h, k plus or minus c. Now using the reasoning above, the equations of the asymptotes are y is equal to plus or minus a over b times x minus h plus k. And then in part A, you can see the horizontal hyperbola, which is centered at hk. And then part B, the vertical hyperbola, which is centered at hk.